Yeah, this in the third part, actually, I will talk about. We have just finished an outline of the main result of Bott and Simonson, and in this section, I will talk about the work of Schubert. In 1958, and the next is Hansen's work. In 1973, and sorry, myself's work. 2005. Yeah, all this work more or less is related to the Bott manifold. We shall see from the next discussion. Actually, the Schwarz's work took place. He used the language of algebraic geometry. The group he concerned with are the so-called the reductive algebraic group. And the subgroup he looked at as a so-called the Bauer subgroup. Actually, but it is well known that reductive algebraic group are one-to-one corresponding to compact Lie group. And the so-called Bauer subgroup one-to-one correspond to the torus subgroup in G. And the fact that K module B is homomorphic to G module maximum torus. So I will feel free to translate the language of Schwarzschild using the language we have already familiar with in the previous talks. I will not make use of the original notion of Schwarzschild, but we can easily translate this into the language we have familiar with. So I also need a bit notation. So let me use L1 to Ln to denote the word of the fundamental dominant. Fundamental well chamber. We don't look at all the well chamber, but just look at a fixed one. We just fix a well chamber and look at the words. I will give an order. We can give arbitrarily an order to this, the boundary of this. The reflections. Generalize. The well group of G. Actually, this sentence means that if you take arbitrary element here, then you can always write W, decompose this W as a product of this generator. So this is this decomposition is called reduced. If R is minimal, decomposition. The fact is that for the given W in the value group, you have many ways to write this as product of these generators. But once the length of this factor is minimal, we call this decomposition reduced. And in this case, let me write L of W to be R, which sometimes is called the length. This is I hope this has been clear for everybody. Yeah, good. Schubert actually he announced this result in 1958, which says that let xw belong to G mod T is a Schubert corresponding to W, then where the dimension of this real dimension is equal to 2 times the length of W. Cell decomposition. Here I didn't talk about the definition of so-called Schubert variety. But once we proceed to the section B, we will know what is the Schubert variety here. Because in Chevalet's work, everything is defined algebraically. It involves another set of notation. But we will see in a moment from Hessen's work, we already know what is Schubert variety. So I just repeat his result. So we keep this. We will explain this later. This result sometimes is well known as the basis theorem of Schubert. This theorem sometimes is called the basis theorem of Schubert calculus. Because you see, in the cell decomposition of this manifold, there are only even dimensional cells involved. So which implies that the cohomology of G mod T has basis spanned by the algebraic cycle with speaking dually, we can introduce the cohomology class by the chronic pairing SW evaluated as XU equal to the chronic symbol, which is 0 if W not equal to U, and which is 1 if W equal to U. So another consequence is this set of class is a basis for the cohomology of G mod T. This class is normally called the Schubert class. Corresponding so this sometimes called Schubert variety. So Schubert class are the chronic dial of the so-called Schubert variety. Variety are something geometrically is a geometric notation. So with this notation, we can talk about the so-called the fundamental problem of Schubert calculus. So let us take two arbitrary Schubert class, SU and SV, and consider their product. So their product is again an element in this cohomology. But this cohomology has a basis, so we can expand this in terms of basis element. Now the problem asks, what is because once these numbers are all known, the ring structure respect to Schubert class will be clear, because this somehow ask for the multiplication table of this basis element here. So this is so let me leave this problem a moment. Let me recall the work of Hansen's work. Actually, you have seen that there are two different ways to understand the geometry or topology of this manifold. One is one approach is by Bort and Simonson from differential topology viewpoint. Their approach is a differential topology. And another is also by many people. I didn't recall some of the early work of this Schubert. Actually start from Schubert, Erisman, Hodge, many people. Then Schubert was able to get this result. But there is a very long history to understand from algebraic geometry this the property of this. Yeah, Hansen's work is interesting because he actually says these two approaches are actually the same thing. So let me. So Hansen unified these two different approaches. Let me put his result as a lemma. Be the Bort cycle. Corresponds then the image of this agree with the Schubert class, a Schubert variety inside this G point T. Yeah, I don't know. This is quite late. Actually, I think this result should happen in 50s, but I don't know why this result of Hansen because of this result, just since this result, since the map GW is called.
This is the work of Hansen, right?
Yeah. Lemma 1, yeah, his work. Just because this map is called the Bort-Simonson. Resolution of this. Of the Schubert variety. This result is interesting because the Schubert varieties contain many singular points. They are not a smooth gap. They are somehow highly singular. But the Bort manifold is a smooth manifold, which is very beautiful, and this map is also somehow ready-made map. The construction might be very easy. So it implies that although this is singular, but you can really find a good manifold and with a good map, which covers this singular variety. So in some sense, yeah, we'll see in a moment what this will happen. Yeah. Yeah, Professor, what's the time now?
11:30.
Yeah, 30. May I have another half hour? This will finish. Okay.
So that means we just finish and then
In half hour.
in a half hour.
In half hour, yeah.
That's okay.
So I will talk about the work of myself. So let me for
In Hansen's work, this variety, singularity,
yeah.
and how there is this correspondence. So the inverse image of the singular set looks
Not so clear. He just established this equality. This equality as a subspace of G mod T. He just
so you can analyze
no. Actually, the singularities in Schubert variety nowadays seems also a topic. But hopefully, we can use this Bolt cycle to study of it.
Vibration structures, so somehow
Yeah.
collapsing some
Yeah.
fibers or
Yeah.
could be possible.
Yeah. I think there are many people doing this, what you have taught nowadays. Okay, so let me fix an element, well group element, and assume that it has a decomposition with reduced decomposition. Where the reflections are all simple, just in the boundary of this fundamental wave cell. And we have so-called the Bolt cycle. Simmons. Or revolution, which is gamma W. Sorry. Which goes into G mod T. But also, this has a structure matrix. One can also read from this decomposition. The structure matrix of this. Yeah, the next thing we look at this map. Actually, this ring is very simple. As we have explained, it is why it is simple, because it is generated by element only in degree 2 and subject to relation only in degree 4. You see. So this is yeah, sorry. Let me see. Where are you? T. So this ring is very simple, but this ring is in question we want to understand for by the fundamental property. So let me take a subset of this ordered sequence. The label of this reflection orders gives you a sequence. It takes value in between 1 and n. Then I will put Wi to be the product of sigma t, where t belong to this subset. Somehow this one is a subword. Is a subword of this word. You just take off the factor which belong to this sub. Then you get rid of the rest. So this is a, in the group theory, this could be called a subword. Of the word. And also I have a monomial here, which is the product of which will be considered as a class here. Yeah, to specify this remap, I need only to look at the action of this on Schubert class will be sufficient, because Schubert class are the basis for this. So I just look at the basis, what happens to this base element. Then the result is, it is the sum of these monomials where the subset satisfies the property that equal to u, and the cardinality of the set is equal to the length of this well group element. In other words, the action of this GW at this Schubert class, you need only to look at the subword whose product is a U, and at the same time, the length of these factors equal to the length of this well group element. I is a subsequence of this I1, R, the corresponding is equal to U.
What is AW?
This
Calculated.
the structure matrix of this.
Structure matrix.
Structure matrix. And belong to the R Wj equal to U to V, sorry. And also here we ask the length of equal to the length of the element, the cardinality of J equal to the length of V. Yeah. This is a sum of monomial. This is also a sum of monomial. So you take product of these two, you get a polynomial up here. You get a polynomial. So actually this factor controls the integration along this variety. So we'll see the proof is somehow straightforward, just only a few lines. So let me give a. So we begin by assume that.
So what is TA, T survey? What does that mean?
The triangular operator. We have talked about the.
What is triangular operator?
Yeah. Let me. Yeah, in the first section, we have talked about the integration along about manifold, and we have introduced an algebraically by induction a sequence of and once this matrix is known, you can do the calculation. So let us turn back to the fundamental problem of Schubert calculus, which asks the coefficients of this expanding of this product. This is should be an equality in the cohomology of G mod T. Yeah, by the property of chronic pairing, with this assumption that we shall have let me fix a W. Fix a W. Then this number is equal to the chronic pairing between SU as V, evaluated as the Schubert class corresponding to the fundamental cycle. This is a chronic pairing between cohomology and homology. Yeah, this normal chronic pairing. But by Hansen's result, this cycle can be written as GW star of Bolt manifold because they have represent the same homology class. Yeah, it's a factorial property of this chronic pairing is that you can move this map in front of this. and to change the induced map on and evaluate the and by the lemma 2 we have this is the same as the part the sum of xi evaluate that here I have simplified this condition. Just simplify this condition. Just put it this way. But this is the same as the integration of along the Baud cycle of the polynomial. So by the theorem of our first section, this is given by so the actual idea of this formula and as well as proof is very naive, very naive. You see, this ring is considered as a very complicated ring. People don't know how to do this for many years. And on the other hand, the cohomology ring of Baud manifold is simple. We just apply this Baud cycle, the map induced by cycle, to reduce the computation here to computation here in a simple manifold. So we can get this formula, yeah.
So theorem, let's see, lemma 2, is this, whose work is this?
Myself, this is, this actually,
so that part seems to be the
so
I mean lemma 2
yeah,
seems to be the main computational.
Yeah. Once this has been done, this will be very easy, and also the integration formula is also is also not known before, but it is somehow straightforward. The proof is somehow straightforward. Actually, this formula is very useful, and in some subsequent work, mainly in joint work, with one of my colleagues, Xue Zhao. We have applied this formula, have computed all the integral cohomology ring of like E8, E7, and also some of the exceptional Lie group module, some parabolic subgroup. All this cohomology ring can be concretely presented in terms of generator of relations. This formula is actually very easy to program using computer. you just need only to input the Gaussian matrix of a D group. Then they give you, produce to you the table for this coefficient. And further program can be added to find the minimum generators and the most essential relations. So this, this in recent years, this can be.
So these computations were done with computer?
With computer, yeah, with computer. So to summarize, I hope that I have been able to talk about the useful part, very useful, interesting, and useful part of this wonderful manifold, Bort-Simpson manifold. It is simple and beautiful, and if you make use of it properly, it can resolve difficulties of other manifold, computation in other manifold. So thank you very much.
Thank you very much. Do you have any? This is limit 2. Can you roughly tell us how this works?
Yeah. Yeah, this is cohomologically, but let me. Yeah, directly we look at the homology. It will be easier. Let me take W gamma GW into G module T. Inside here you have various kind of Schubert varieties. You have Schubert varieties. So from the construction of this gamma, you suppose we have a subword of this omega, says W, a subword of this W. You will find that the corresponding Bort manifold is a submanifold of this one. And if this word is equal to this one, by the Husson theorem, this maps this submanifold onto this guy. But if not equal, the image here will not be. So if you then you look at the induced cohomology map from here to here, it says that these cells corresponding to all these submanifolds, so that this is a subword of it, and U is. So this is a geometry to interpret this. This is a cohomology way, but this is a homology. Yeah, this is the key part of this calculation. This is really good. Actually, this is precisely the top degree class of this one.
Top degree?
Top degree, yeah. You see, in this Bort manifold, if you take the product of all these generators, it is exactly the generator of the top degree. So, so this part is the top degree of this cohomology class of this one.
Yeah.
So in other words, if you look at the induced map, its image is some of those top top degree of those sub Bott cycle, such that the corresponding word agree with this U.
Thank you.